Think of the Arctic. It's 40 degrees below zero, 100 degrees below zero, blowing snow. How does that cable survive there?
The RF world is very competitive. We need to provide a quality product at a reasonable cost.
And this is where we come in. In order to deliver those high performance cables, you need to have high performing insulation materials.
A carrier has a lot of challenges in front of them, and they want to know that when they install our cable, it's going to perform the way they want it to perform. They look to us to help them sleep at night knowing that their infrastructure products and their cable products are performing the way they want.
We did spot the trend and the need for these higher performance cables. So we already started to do some work with our R&D folks. The next step was really to find a suitable cable manufacturing partner. And RFS was really the right candidate because they have a great reputation for manufacturing high quality, high performance RF cables.
20 years ago, it was the explosion of the cellular industry. And the big challenges were getting the product out because it was a big uptick in demand and addressing loss. So it was very, I would say, simple in terms of the requirements and very straightforward. The industry has matured, become much more complex thanks to all these great advancements. And as you would expect, the requirements for cable have evolved.
In radio frequency cables, really the presence of impurities in the insulation material can be very detrimental to the efficiency of the signal. What is critical for us is to ensure that throughout the supply chain, from the raw materials that we use, from the manufacturing process that we utilize, to the packaging and the transportation of the material to our customers, that no impurities enter the system.
The chemical composition of the cable is very important because the electrical performance can change if that chemical composition changes slightly.
Here at RFS we do a series of qualification tests that take into account what we call accelerated aging, and that part of the mill standard that we use, and it accelerates the aging, and we measure the performance of the cable after we perform those tests. So there's a test before and then after, and we see if there's any change in that performance.
They're looking at specs of the cable throughout the run to see if there are any imperfections or changes within the cable, and then the consistency of that cable, both when they install it and over time.
Dow offered us an alternative compound that we had not been using, the Acceleron 1258, which showed an improvement to our product with no change in cost. The Acceleron 1258 through the supply chain is delivered to us directly into our silos, and it cuts down on the amount of contamination that could possibly get in there. So the product is very clean when it arrives here, and the way we handle it, it's very clean, and that helps produce a better product. In this case, the 1258 is unique in that it has a property in it called dissipation factor, which is lower than what's been used in the past. And this dissipation factor allows our cable to promote or give out more of a signal to the antenna. So there's less loss within the cable due to this lower dissipation factor. RFS goes to great lengths to keep moisture out of its cables. The Acceleron 1258 is one component or one piece of a whole system that's developed inside of that cable. So in the foam process, we generate or extrude a closed cell foam, and that closed cell foam keeps the water from migrating through the foam. That foam also binds to what we call a copolymer, which is on the center conductor, and since it adheres to that, there's no water entry path along the center conductor. RFS corrugates its cable annually, meaning it's individual rings where most people are used to a helically corrugated or a screw. So these individual rings then bind or compress into the foam and act as individual water blocks on the outside. So there's three ways that the Acceleron 1258 helps with water migration: closed cell, adherence to the center conductor, and compressing, being able to be compressed by the outer conductor and forming those individual blocks. We noticed the improvement immediately. Right after the first prototype was manufactured, it goes to electrical testing. There's a series of tests that the cable would undergo, the most important of which is attenuation. And that's where we saw the benefit of the lower dissipation factor, that we had an improvement of 5% over what was being shipped prior to that. So again, the benefit was immediate.
They wanted to deliver high quality cables, we wanted to deliver high quality materials. The collaboration was perfect. We achieved our goals, we achieved high performance, and we're already looking at new areas for us to work together in the future.